Happy Black Friday, everybody. This is a live severe weather update as we have a marginal severe weather threat today across East Texas, including the Houston area today. But it does look like a pretty marginal setup, but a textbook setup across the Houston area where we often see tornado warnings and even some confirmed tornadoes. And that marginal risk extends east all the way through Louisiana as well, mostly coastal Louisiana. And conditions are already favorable for supercell storms and even a tornado threat this morning. And I'm going to show you why I believe that. But we've already got a supercell just to the north of Galveston that is crossing over Galveston Bay right now. And it does have a textbook RFD structure and a hook echo that has formed. Here you can see that RFD structure right there. This is the hook-like appendage, a very tight gradient as well along the forward flank gust front. So there's very possibly a waterspout happening right now across Galveston Bay. This is to the northwest of the Bolivar Peninsula. This down here is Galveston Island toward the mouth of Galveston Bay. Or that's actually Bolivar Peninsula right there. This is Galveston Island and Galveston. Here's the Bolivar Peninsula. And if you're on the Bolivar Peninsula looking north across Galveston Bay, you're probably going to see this supercell that's in progress right now. And it could easily have a waterspout. You may remember that event earlier this year. I think it was during the summer where there was that monster waterspout over Galveston Bay. Let's take a look at the velocity imagery. And there probably is a forming waterspout, definitely a wall cloud, maybe a waterspout already in progress here. It doesn't seem incredibly tight, but this is a very well-defined mesocyclone here on the northern side of Galveston Bay. Here you can see the wind coming in toward the radar. This is it going away. This is basically that RFD structure, but this overall right here is the mesocyclone above it. And so if this did produce a waterspout, it would be a supercell waterspout, which is basically the same as the tornadoes that you see across Tornado Alley associated with the mesocyclone. They could come ashore on the periphery here of Galveston Island and definitely cause some damage. Here's this RFD gust front. It's a little bit elongated right now. You can see some anomalies here along the forward flank gust front. Inflows coming in just ahead of the RFD gust front. So it doesn't look tornadic right now, but it is close right here in the notch between the intersection of that RFD gust front and the forward flank boundary there, gust front as well. The intersection of those two, that's where you want to look for tornado formation. Right now there's definitely a wall cloud in that location. I could tell you that without even looking at it. You're probably also this beautiful elongated RFD shelf cloud also over Galveston Bay. And the rotation has subsided just a little bit. This is that RFD gust front here. The westerly winds surging behind that gust front. You've got inflow coming in out ahead of it. You've got some winds out of the due east as well to the north of the forward flank. Eventually those become northerly on the backside. So this is the area that you'd want to watch for that waterspout formation. And there is already a potential for supercells and tornadoes across southeastern Texas. And I'm going to tell you why that's the case right now. Here is the 500 millibar map. And this isn't an ideal shape for severe weather for Houston, but it is kind of a textbook setup with this subtropical connection. This is the subtropical jet down here, helping to dig this low a little bit further south of the Four Corners over the southwestern U.S. This is the main polar front jet stream off to the north up into Canada. So you got a big ridge that's building right here, but this cutoff system is eventually going to signify or at least lead the way for a big-time pattern change and a lot of cold air dominating the eastern U.S., including a stripe of snow that's going to move from probably near St. Louis up through Detroit. Let me turn off this iMessage here. And but there's a little bit of ridging aloft downstream of this upper level low. And this upper level low, though, is what's responsible for the severe weather threat today across the Houston area, southeastern Texas there. Pretty textbook event where you get this subtropical connection right here. You've got a cutoff low way upstream. And you've got a belt of pretty strong mid and upper level flow extending way off to the south. And I'm going to turn that down just a little bit. Hopefully the audio is still working here. There we go. That'll turn off that iMessage. But this is the upper level system. And you've got a belt of a subtropical jet stream extending south, and on the southeastern side of that upper level low, a little bit of slight ridging over the southern plains. But this subtropical jet here is going to create some isentropic lift over a stalling cold front that's approaching the Gulf Coast. But anytime you get a 50 to 60 knot mid and upper level flow, there's probably going to be plenty of bulk shear for supercell development. We've already got a supercell over Galveston Bay right now. Instability is already building along the coast out ahead of that front. But there is quite a marginal low-level jet, and that's because of the unfavorable shape of this upper-level system. So then you look about a kilometer above the ground. This is at 850 millibars, and notice how you don't have that monster low-level jet that we had, for example, with that last system that led to an EF2LCS tornado in Arlington, Texas. That shows you the power of the low-level jet, even with low-level surface-based instability. May not be that apparent. If you get a strong mesocyclone fueled by a strong low-level jet, it can easily drill through that stable layer. But with this cutoff upper level low, basically a closed low way to the west of this subtropical connection, you don't have that big open wave that gives you a lot of vorticity advection downstream and a lot of pressure falls as well over the higher terrain, and that excites a big southerly low-level jet to the east of it, and that gives you the low-level shear that you need for large-scale tornado events. In this case, with that unfavorable shape to the upper level system, we basically have about 15 knots, 15 to 20 knots at 850 millibars out of the southwest. And that's probably not going to be enough to cause a substantial tornado threat, but it is enough to have a marginal tornado threat, and there's plenty of bulk shear for those supercell storms. We already have a supercell storm right now on the northern side of Galveston Bay that we're watching closely. But you just don't have that powerful low-level jet downstream. If this were a big, deep open wave, high-amplitude open wave like that, then you get those big pressure falls to the west over the high plains, and that would accelerate one of those big, like 50-knot low-level jets that would transport moisture way to the north and lead to a big outbreak of severe weather. In this case, you have a cutoff system way to the west. It does have a subtropical connection, and that's causing that strong mid and upper level flow to extend well downstream of that upper level low. And we just have some subtle forcing with a coastal front that is stalling out over southeastern Texas. And that's why we have this marginal threat for severe weather, including the Houston area. And the Storm Prediction Center has added a 2% risk for tornadoes there as well. But there definitely are some negatives with this setup. But there is plenty of instability in place across southeastern Texas. A little bit of sin over the Houston metro, but it's probably some type of a model analysis anomaly. But in general, we have modest southerly winds at the surface at about 5 knots, pretty weak southerly winds. And then we've got 850 winds out of the southwest at about 15 to 20 knots, creating pretty weak low-level shear. But with a little pocket of about 25 to 30 knots over the Houston area, that's popping up those storm relative effective velocities of above about 150 meters squared per second squared, which is marginally favorable for the development of low-level mesocyclones. But if this were more of a coastal warm front with those backed winds along it, if we had easterly surface winds beneath those southwesterly 1 kilometer winds at about 15 to 20 knots, then we'd probably be talking about a more robust tornado threat, a slight risk for severe weather in that case, and maybe a 5% tornado probability. But in this case, with relatively unidirectional flow, maybe a little bit of some backing here being influenced by the shape of that coastline around Galveston Bay, maybe leading to an enhancement of low-level shear there, and maybe the development of a waterspout over northern Galveston Bay. But in general, we've got 1,500 to 2,500 surface-based capes, and that stretches eastward across the southern third of Louisiana too. That's why that marginal risk also extends downstream just a little bit. But this is showing that thermodynamically, southeast Texas and southern Louisiana is already supportive of supercell storms and even a tornado threat. And the same goes for the low-level wind shear in the latest RAP analysis. It's only about 10-15 out there. Central Standard Time, so late morning. But that's often when these setups can produce. And the wrap is definitely showing some surface-based storms and even supercells, supercellular modes developing within that environment over southeastern Texas. And we've already got up to 200 0 to 1 kilometer storm relative helicity in southeastern Texas. So it is marginally supportive of tornadoes when these supercells are moving into that environment. But this wrap analysis definitely is picking up on the supercell storm that's already in progress over Galveston Bay in this environment that is marginally supportive of even a development of tornadoes. So we're going to look at some forecast soundings that are representative of this environment right now over the Houston area and southeastern Texas. And this convective line is going to be marching to the east across southwestern Louisiana, southern Louisiana there. And back where the instability is even stronger, back toward Victoria and Corpus Christi, not as much in the way of convection. So there's definitely a subtle subtropical impulse embedded within that subtropical jet that's leading to the development of these supercell storms that are moving to the east through the Houston area, and eventually are going to march off to the east across southwestern and southern Louisiana here as we go through the afternoon hours. Looking at the surface map, it confirms those southerly winds that are analyzed by the wrap at the surface. Weak southerlies, though, 5 to 10 knots in this environment. Very moist environment and unstable, with temperatures rising through the mid-70s already this morning. And it's just after 10 a.m. right now. There's a dew point 74, 73 dew point there to the southwest of Houston. And here's this weak front. So you look at the winds back behind the front that are out of the north. And these winds are weak too. You can see the 5-knot flag right there. That's a 5-knot northerly wind off that dramatically back behind the front. So we're not going to see a surging front that's going to be undercutting all these storms all day. You're basically seeing a stalling out front as it's approaching coastal Texas here. And there's just going to be subtle lift over top of this front. A little bit of convergence with the winds to the north of it. About 5 to 10 knots out of the due north, winds to the south of it, 5 to 10 knots out of the due south, and those converging winds there are going to be the focus for severe thunderstorm and even supercell development this morning through the afternoon hours, and that is going to extend to the east across Louisiana, where temperatures are also in the 70s with dew points in the 70s. But really what you need are more of these easterly winds, more of a coastal warm front scenario here, for this to be more of a robust tornado producer across the Houston area, coastal Texas and Louisiana. If you had those surface easterlies, then that would be enough to really enhance that low-level shear to have a more substantial tornado threat. Nevertheless, though, the Storm Prediction Center has painted a 2% area across southeastern Texas, basically in an area like this across the Houston area, where you have the greatest co-location of surface-based instability and marginal low-level shear out there. And here is the marginal risk from the Storm Prediction Center, with those greatest tornado probabilities back here across the Houston area, southeastern Texas. And now we're going to be looking at some of those forecast photographs here quickly. Thank you guys for joining me here on this live severe weather briefing. And I'm going to be chasing this system on the day 3 when there is a severe weather threat and even some possible tornadoes to the east of the Piedmont, probably central and eastern North Carolina. That's the area that I'm watching most closely. Here you can see some of those 850 winds, even up there near 30 knots. So this is the strongest wind shear, and that's as of 14Z this morning. This is a little bit more current, and you can still see those 850 winds accelerating over 20 to 30 knots there in the Houston area out of a southwesterly direction. So there is a little bit of a low-level jet response with this subtle disturbance within the subtropical jet, and that's just enough to really boost those low-level shear values. And these are inflated by storms, some northerly surface winds. So in general, across the Houston area, you've got 0 to 1 kilometer storm relative helicity on the order of 150 to 180, maximized from the Houston metro through Beaumont into southwestern Louisiana. and this is by 17Z, which is about 10 to 11 a.m. So that's about 11 a.m. coming up here in 45 minutes Central Standard Time. So this is pretty representative of the low-level shear. Definitely enhanced by that southwesterly wind pop of 20 to 30 knots at 850 millibars. But overall, not a very favorable synoptic scale system to produce widespread severe weather. But there is a chance that you could squeeze out a favorable environment for tornadoes, especially if you can get some locally backed surface winds. In this case, basically a due southerly wind of about 5 to 10 knots. But it is generating a hodograph that looks quite favorable for tornadoes. You've got a due easterly storm motion of about 30 knots there, creating a near 90 degrees critical angle. Here it shows the critical angle near 80 degrees, but pretty weak flow. That's because you don't have a very deep open wave or a big time storm system coming in here. But still, you've got turning in the lowest 3 kilometers. Despite these southerly winds at about 10 to 15 knots, your 1 kilometer wind due southwesterly at about 25 knots, that's your low-level jet. Just sufficient to generate this storm relative helicity within that hodograph curve. That's what this is right there. And I could go over how you plot these hodographs as well really quickly. Take a frame capture and open this up so I can annotate it. Is that a bird? So here is the hodograph. Let me pull this up really quickly. And I'm going to show you how these are plotted. But really what you want is a curved hodograph, just how this one looks. Normally you want the low-level flow to be a bit stronger to have a robust tornado threat, but these hodographs actually do look surprisingly favorable for a threat of tornadoes. So this is the surface wind, and basically you're looking down at the atmosphere, and each of these rings right here represent a magnitude or a wind speed. That's the 30-knot ring. This is the 40-knot ring right there. And wind direction is defined by wind speed, or wind is defined by wind speed and wind direction. So you can plot those as a vector. And the surface wind right here, this is plotted as a due southerly wind. Basically, you plot where the wind is coming from. So that vector would look like this. It's an arrow. It also has a magnitude. The southerly wind is about a little over 10 knots in this case. Due south, a little bit west of due south, but that's that surface wind vector. And then you plot the wind vector up about a kilometer in this case, but also 500 meters and all those layers in between. And so then the wind at about a kilometer above the ground is a little closer to due southwest and a little stronger at 25 knots. So that's the wind vector at 1 kilometer. The wind vector at 2 kilometers, a little stronger and a little more westerly, almost due southwesterly there, at closing in at 30 knots. And this is a favorable pattern for tornadoes, is to have these almost due westerly 3 kilometer winds. So those are very veered winds. You can see a lot of changing wind direction with height, going from nearly due southerly at the surface to almost due westerly at 3 kilometers. And then the hodograph curve is plotted by connecting the tips of these arrows all the way around. And then you've got these upper level winds as well, closer to due westerly. This is that subtropical jet stream up here that's going to be providing the strong, ample mid and deep layer shear, the bulk shear to get supercell storms. These are the winds that are responsible for evacuating that rain and the hail from the mesocyclone, so you have a long-lived mesocyclone. These winds at the lowest levels of the atmosphere are responsible, though, for the tornado production portion. And if you don't have strong low-level shear, you're simply not going to get tornadoes. And to get a really robust tornado threat, you'd want a low-level jet up near 40 to 50 knots like this. So that would be a big curved hodograph. You'd have a lot more low-level shear. So when you're looking at a hodograph, the storm relative helicity is proportional to the area within the hodograph curve. So in this case, with this hodograph curve looking like this, connecting all those arrows of the winds, the area encapsulated by the storm motion vector and the hodograph curve is proportional to the storm relative helicity. And in this case, that's storm relative helicity that's conducive for a tornado threat across the Houston area. There is just a little bit of veer here, where this area to the north of the hodograph is a negative contribution to the wind shear. But this area underneath the cyclonically curved portion of the hodograph corresponds to positive storm relative helicity contribution. And this is the storm motion vector down there. This little circle showing due easterly storm motion at about 30 knots. That's that storm motion vector. 30 knots is the speed. The direction coming from the west when you're plotting a hodograph like this. Basically, it's like you're looking down at the shear profile of the atmosphere, and if you embed a storm inside this environment, this hodograph curve, or the winds that that storm is exposed to, are going to cause that storm to rotate or not to rotate. And this hodograph tells you how favorable the wind shear is lined up. You want to look for the critical angle, which is the angle of the storm motion vector, with the 0 to 1 kilometer, or basically 0 to 500 meter shear vector. In this case, your 500 meter shear vector is like that. And your storm motion vector, the angle that it makes with that curve, that's the critical angle. And that's listed on many of these plotting packages. This is the pivotalweather.com website here. This is the motion of the left moving supercell. This is the motion of the right moving supercell. I believe bunkers derive storm motion. Basically a weighted average of the winds from the lower troposphere up through the mid and upper levels of the atmosphere that storm or the obstacle within is exposed to. But this is the hodograph. Probably the most useful tool to assess just how favorable the shear profile is for tornado-producing storms. And this hodograph is representative of that environment near Houston. That's why the possible hazard type here is identified as a tornado. Critical angle, really close to 90 degrees. You really don't need a critical angle this close to 90, but in this case, with relatively weak low-level flow, with a low-level jet of only about 20 to 25 knots, you really need a critical angle, almost exactly 90 degrees, to realize the tornado threat. Thermodynamically, let's look at the sounding here. Very moist, 77 degree temperature, 73 dew point. The low-level lapse rates could be, well, the low-level lapse rates are quite steep. So that's one positive factor for this setup for a tornado potential. You also have a very weak cap, very easily overcome, well above the convective temperature, or very close actually to the convective temperature of 81 degrees. So as we're getting approaching 80 degrees, that means we're going to get the development of surface-based storms just forming in the open warm sector on any convergent boundary. This sounding also has close to 2,500 CAPE, a lifted index of -7. So pretty steep low-level lapse rates here, a lot of CAPE. This is the parcel temperature on the way up, and you can really see that directional shear between the lowest 3 kilometers, going from south-southwesterly wind almost to due westerly at 30 knots at 3 kilometers. So your 0 to 3 kilometer shear is a lot higher than your 0 to 1 kilometer shear. But if you did have an easterly surface wind there, that would really inflate that low-level shear quite substantially. Let's see how that low-level jet here on the models. Notice how it weakens a bit as it passes in to southern Louisiana through this afternoon. So even though that marginal tornado threat extends to the east, and it looks like it's over by about 3 to 4 p.m., especially in the Houston area. So this is a late morning into early afternoon severe weather setup for Houston. And by this time, the low-level jet is starting to weaken a bit as it closes in on the Lafayette region, south-central Louisiana, eventually into southeastern Louisiana. But there still is a chance that you could squeeze out a quick tornado, maybe a water spout on Lake Pontchartrain with that environment. 0 to 1 kilometer EHIs are marginal out there as it gets into southeastern Louisiana, but that's where the marginal threat for severe weather is going to shift as we go into the mid and later portions of the afternoon. But out here in Texas, you can see much higher 0 to 1 kilometer EHIs as we're going through the late morning hours. And this is why we already have a supercell storm with waterspout potential over Galveston Bay right now. We've got a 0 to 1 kilometer EHI approaching 2 there, even above 2 to the north, just near the Houston metro. But then as we go through the afternoon with that weakening low-level jet, it seems the wind shear seems to subside as we get closer to southern Louisiana. Look at that. And this reduction in the EHIs is not from a reduction in CAPE, but from a reduction of low-level shear. Maybe a bit of a reduction of CAPE there out over the marshlands of southeastern Louisiana. Most of the CAPE is from the Houston metro west and southwest. But then that subtle disturbance moves to the east through southern Louisiana, eventually southeastern Louisiana, with a marginally favorable low-level shear. There's that CAPE right now. Most of it's to the west of Houston where there's less low-level shear. And then where there's a bit of a reduction of CAPE, that's where you get the 0 to 1 kilometer storm relative helicity of about 150 to 200. But you get the best overlap of thermodynamics and wind shear near the Houston metro. That's for sure. Here you can see the convective line. The HRRR does not resolve the supercell over Galveston Bay very well. It just convects the stalled out front where you have that sustained low-level convergence with the northerlies to the north of it, the southerly winds to the south of it. But definitely has these supercell storms evolving over the Texas piney woods to the north of Houston, eventually moving well to the north of Lake Charles by 17Z as we're getting toward noon. The HRRR then begins to convect the coastal area here, this zone to the west of Houston where you have that Cape Max, and then these storms are likely going to march into this more favorable low-level shear for tornadoes from Beaumont east through the Lake Charles area. So by noon, we've got to watch the development of these storms through Houston area, Galveston Bay, downtown Houston. But by this time, by 19 to 20Z, the low-level shear begins to weaken, and this convective line is more shear parallel by this time. It's just going to slowly sag into southeastern Louisiana, where you've got those dew points in the 70s, but more marginal low-level shear. And then it's the end of this event. And so there's not a risk for severe weather in day 2, but then day 3 there is a marginal risk out here in the Carolina Piedmont as this upper-level system finally ejects. So let's take a look at what the GFS does with that. And there's a lot of model discrepancies for how this pattern is going to play out. But I do think there's going to be a severe weather threat across central and eastern North Carolina, maybe even southeastern Virginia up there. And a stripe of significant snow extending maybe from the St. Louis area through Detroit, ramping up in southern Ontario. And a big lake effect event is anticipated for the Cleveland snowburbs out there. Cleveland, Erie, looks like more of a northerly, northwesterly type, maybe a double fetch event off Lake Huron over western Lake Erie, the thick portion of Lake Erie there from a north-south perspective. And it looks like there could be some pretty good snow for Cleveland, first big snow of the year. But first, let's see how this system evolves. Normally, you'd expect this event to bring some marginal severe weather for the lower Mississippi River Valley, but there is kind of a diffuse low-level jet. Still, though, low-level jet in near around 30 knots there near the lower Mississippi River Valley into southern Mississippi. Looks like there could be some severe weather tomorrow afternoon. Mississippi, Alabama, as that low-level jet pushes off to the east. Very marginal instability down there, though. See the coastal front. I mean, most of the instability is over the Gulf of Mexico. So that's going to be a limiting factor for severe weather tomorrow. Really, CAPE only on the order of about 300 to 400 out there across southeastern Louisiana. So that's why tomorrow there is no risk for severe weather, but there could be some marginally severe storms across coastal Mississippi, coastal Alabama tomorrow. And then as this system ejects over the Carolinas, that's the event that I'm looking to chase. So this is Monday at 18Z, and look how this system just phases with the northern stream. Still basically a cutoff system here. Then you've got this clipper, a pretty potent wave diving down into the Great Lakes. And the phasing of these two systems is going to create a big time snowstorm for somebody. Probably some severe weather over the Carolinas, depending on the timing of this phasing. But textbook phasing of the northern branch and the southern stream system here being depicted by the GFS. And this becomes a intensifying upper level system with all of this flow on the backside of it. Backside loaded system. That's a deepening upper level system as it's approaching the eastern U.S. By 18Z Monday, look how the system continues to intensify, developing more of a neutral tilt. The GFS shows the low-level jet basically focused across eastern North Carolina and eastern South Carolina, where there could be some severe weather. But I don't know if I buy this hole here, the low-level jet. This could easily be just a solid low-level jet across the mid-Atlantic region, down through the central and eastern portions of the Carolinas. The timing of that is going to be very key. Let's look at our forecast sounding here in eastern. That is unfavorable there. Big elevated mix layer coming in over top. I do think somebody's going to get some severe weather in this. I think the Euro is a bit more. So the European has a more robust low-level jet hanging on here in eastern North Carolina, northeastern South Carolina. This is 18Z Monday. That's a 60-knot low-level jet there. Also across southeastern Virginia. So that's a little bit more favorable than the GFS. The GFS has this big hole in the low-level jet over the mid-Atlantic, which probably isn't going to happen. Probably more of a clean phasing of the polar front jet and the southern stream. So I'm going to either chase the severe weather across the eastern North Carolina, maybe even northeastern South Carolina, and then retreat and cover the wind and snow squalls across the mountains there of western North Carolina. And then there's likely going to be a stripe of snow just to the northwest of that 500 millibar low track. It looks like Detroit could get hammered. Cleveland's going to get hammered with lake effect and enhanced snowfall too off western Lake Erie. Southern Ontario is going to get hammered by this, as we're kind of bouncing between the GFS and the Euro. This is a surface low track here on the European. It's a little bit further east, and that would take that track directly over Cleveland. Kind of an Indianapolis, Cleveland type of a track there. And look at that lake enhancement along the lake shore. That would bring in Cleveland in excess of a foot. Erie gets hammered. Synoptic scale snow and mainly lake effect, lake enhanced snow in the backside of that system. And then it really ramps up across southern Ontario into Quebec. Well in excess, approaching a foot and a half, even 2 feet up there in southwestern Quebec. And there could be several inches of snow too across the mountains here, the Smokies, western North Carolina, kind of the spine here of the Appalachians. So I'm probably going to chase the severe weather event in eastern North Carolina, southeastern Virginia, and then retreat west and cover the big wind and snow squalls here over the higher terrain of North Carolina, Tennessee, up through West Virginia. I'm located right here, so that's a pretty easy trip up to the top of Grandfather Mountain. Let's see what the GFS has up there. Look at the GFS. Just a monster stripe of snow. Hammering Cleveland. So the GFS has approaching 2 feet of snow across Cleveland. Southwestern Ontario there, downwind of Lake Huron, where you get that double fetch, that lake enhanced snow off Huron, and then off the west side of Lake Erie. Cleveland getting hammered. Detroit could get in on the action too. Maybe get some lake enhancement up from a north-northeasterly wind off Lake Huron, Lake St. Clair there. So the European and GFS, still quite a bit of a difference in that stripe of snow. The European shows a little less snow, but still both models show big-time lake-enhanced snow across northeastern Ohio, northwestern Pennsylvania. Even western New York gets in on the action as that low lifts off to the north. So if you live in Cleveland, this is a pattern to be excited about as a weather enthusiast, that's for sure. NAM just doesn't quite go out far enough. Shows some the Panhandle getting several inches of snow there as well in the NAM. Interesting. Here you can see the phasing of these two systems. So the NAM is interesting on Monday, lifting this cutoff system as a little lobe on the eastern side of the now parent trough as the polar front trough takes over. And look at this little cutoff system lifting up on the east side as a lobe of enhanced vorticity. And this could bring Carolinas to eastern Virginia on Monday morning and Monday afternoon. And then behind this feature, big snow squalls come in to the Smoky Mountains, southern Appalachians there, the spine of the Appalachians. And then we're going to have a big surface low lifting up to the north, probably near the Pennsylvania-Ohio border, maybe a little east of there. And that's going to bring that stripe of snow right through Cleveland. Dayton could get in on the action. Southern Ontario, Detroit. Absolutely textbook upper level system here. Phasing happening. Some right entrance action here of the jet is going to cause that surface low to really bomb out. The NAM has it even further east than the GFS. Be a GFS fan. See how much further west the surface low is on the GFS? There definitely is some discrepancies between the exact track with the GFS taking it over Pittsburgh, the European a little bit further east, and the European and the NAM seems to be in line with the European model. But then all this lake-enhanced snow on the west side of that surface low, deformation zone. The lakes are still incredibly warm out there. Lake Huron, Western Lake Erie. All hell is about to break loose here. And by this time Monday afternoon, too, you're going to want to watch this front. That's going to be over eastern North Carolina with the potential for severe weather out there. Could be over the Outer Banks by this time, but looks like a little bit too progressive to bring big severe weather, but still Monday morning. We'll definitely have to watch somewhere to the east of the Piedmont here for severe weather. Winter weather alerts coming maybe for southern Appalachians. Probably going to need some winter storm watches as we go through the weekend here for Cleveland, maybe even portions of Indiana. So a very exciting pattern ahead for weather enthusiasts, and there could even be some severe weather across the mid-Atlantic here, but could be limited a bit by instability, even though you've got some mid-60s dew points lifting up into eastern North Carolina here on Monday afternoon. So let's go back and start looking at that severe weather now, that is. And they did actually finally issue a special weather statement for this as it moved through. Looks like it could have produced over Smith Point there. Could have produced a water spout. It is weakening just a little bit. It looks like it is pulling in some inflow from the east here, though. So there could be some terrain features that lead to locally enhanced low-level wind shear. Let's increase the number of frames here so we can see the whole evolution of this. So it could have produced a, look at that, it did produce a water spout right there. Just north of Smith Point. Right there is when that water spout likely happened. You can see that hook come around. Likely an enhancement in the velocity too there, passing over Galveston Bay. Probably could have prompted a tornado warning there, but they did issue a special weather statement. Probably mentions heavy rainfall possible with this storm. Strong thunderstorm near Smith Point. Pea-size hail. No mention of water spouts, interestingly, but I think it produced a water spout. I think they missed this one. There's the velocity pop there, just north of Smith Point. Probably enhanced by that terrain influence as well. So right in there. It does look like there was a water spout that passed just to the north of Smith Point. It's kind of the end of that elongated RFD, kind of wrapped up. You got to watch out for those long appendages because that means that there's a long area of potential vorticity here. And this water spout ended up forming right at the tip of it. You had a little RFD surge, probably aided by the terrain here, the mouth of Galveston Bay, just to the west of Smith Point. And then that caused the end of this appendage to wrap up and develop a water spout. Look at that. Look at that hook right there, aided by the terrain. Just west of Smith Point. Probably should have been a tornado warning there. Beautiful storm, though. And this was at 11:09, so just a little bit ago, toward the beginning of our briefing. But here you can see the forward flank gust front, and usually the tighter the gradient here in reflectivity, the more textbook the supercell. Here you can see the hook, of course, hook-like appendage. The rear flank downdraft would be like this. Rear flank downdraft gust front. This whole area here is a rear flank downdraft, and then that causes these west to east oriented winds to gust out behind it, enhancing the cyclonic vorticity to the north of the RFD. And aided by the topography, the mouth of the Galveston Bay here, accelerating that low-level jet to the southeast of it, definitely aided in the formation of that water spout. But you could look up a supercell diagram in Howie Bluestein's book, and they look like this. In his textbooks. There you can see the supercell, the forward flank gust front, even some wake eddies downstream. You can see the flying eagle configuration embedded within this. This is the subtropical jet carrying those hydrometeors way downstream there. This is some wake low back in the backside of it, back behind it. Sometimes you'll get this train of radar echoes on the backside of these supercell storms. But this is a textbook supercell storm that was approaching Smith Point, likely produced a water spout just to the north of Smith Point there. We were watching this very closely at the beginning of this live stream. There you can see the spout water spout. So it was just ramping up here, but here you can see the enhanced westerlies in the RFD just as it was about to drop that spout, as that hook was coming around, and then it closed all the way around, occluded a bit. Here you can see the forward flank gust front, the boundary there. And there was likely a water spout just offshore Smith Point there in Galveston Bay, well to the northeast of Galveston, well to the north of Bolivar Peninsula there. Bam. There you can see it. Looks like it produced over here to the north of Smith Point. So that's it. A water spout. And that was created by environmental conditions that were favorable for severe weather. Here is the instability from the latest RAP analysis, 1500 to 2500 Cape. A lot higher to the west of Houston, but more favorable low-level wind shear for tornadoes, the Houston metro and to the east and across southwestern Louisiana. But that's going to decrease as we go through the afternoon, mid to late afternoon, especially across southern Louisiana. We're going to see a reduction in that wind shear. But right now, the wind shear is definitely favorable for low-level rotation. The bulk shear, mid and upper level wind shear, very favorable for supercell storms. And we're all over it here. Team Dominator headquarters, watching this severe weather closely. Let's zoom out and see if any other storms are going to develop. The HRRR showed that there would probably be additional development back here to the west of Houston, southwest of Houston. closer to midday, maybe the next 1 to 2 hours. But right now, and the HRRR did pick up on these kind of elevated monster blob, almost HP supercells, but it didn't pick up on this one developing this early in the day across Galveston Bay. But this storm here could very easily leave behind an outflow boundary that could definitely enhance the wind shear for further development that is anticipated by the HRRR in the next 1 to 2 hours to the west of Houston and northwest of Houston. So I do think there's going to be more surface-based supercell development to the west of Houston here, eventually moving into the metro. And if this little storm leaves behind an outflow boundary and they interact with it, that could locally enhance the tornado threat too to the south and to the southeast of Houston. So we're going to keep a close eye on that as well. It looks like it could regenerate. So based on, looks like some of these storms are trying to form on the outflow of that first one. This one right here. This is the next storm to watch. This is just to the southwest of Houston right here. And this one looks like it's forming on the outflow of this lead storm. And there is low-level wind shear that's at least marginally favorable for tornado genesis here. So let's watch this storm as it matures, eventually approaching Galveston Bay. This storm looks like it's reinvigorating to the north of the Boulevard Peninsula as well. Might need a tornado warning shortly for this. It's approaching High Island as well. Forward flank gust front, rear flank downdraft surging out. Looks like there could even be a little bounded weak echo region there. Not a lot of rotation yet, but you can see the enhanced westerlies with the rear flank downdraft there. Some broad storm relative inflow to the north of that, but I expect to see the rotation reinvigorate with this storm on approach to High Island, and I wouldn't be surprised if there is another tornado warning issued. Looks like it's starting to reinvigorate a bit over the marshland here to the west of High Island. This is actually the same area where we saw that cattle evacuation ahead of Hurricane Laura earlier this year in August there. Hurricane Laura, though, went well to the east of this area in the end, coming in there near Creole, making landfall to the east of Cameron, near Cameron. But this storm, I expect, has the more immediate tornado potential approaching High Island, Texas, to the northeast of Kaplan, north of Kaplan, northeast of Crystal Beach. It's kind of losing its punch. I think there is a little bit of convective inhibition at the low levels here, as sampled by the RAP. Here you can see some of that convective inhibition there across the coastal areas to the east of Houston, including the Boulevard Peninsula. It might be, this storm could be getting a little impeded by that low-level convective inhibition that maybe wasn't present as it was passing over the very warm waters of Galveston Bay. But that's the storm that we're watching right now. Still is a supercell, well-defined supercell, and a hook-like appendage on the southwest side. And it seems to have a clean environment out ahead of it. Clean, very moist environment. Probably about 76 over 73 type of an environment out ahead of it. So very moist and unstable. Steep low-level lapse rates as well, as we've had some heating. So I'm going to continue to go live like this throughout the day. And I'll probably be in chase mode. The event comes into the Carolina Piedmont. And I'm also watching this area to the west of Houston for additional development of supercell storms. And I hope you guys enjoy my weather reports. Stay tuned. I'll be back live